We're now going to look at how to differentiate some more complex functions. Not trig functions like in the last lessons, but functions involving brackets into the power of. So if we look at this function here, for example, y equals x plus 4 to the power of 3, and we were asked to find the derivative of this. Normally what you would do is you would try and multiply the brackets out so you've got lots of different terms and then differentiate them individually. So let's have a look at how you would do that. I'm just going to show you this quickly. There's a lot of algebra involved and we're trying to find a better way than this, but this is a way of doing it. So if you wanted to multiply that bracket out, you would split it into x plus 4 times x plus 4 squared. You can then multiply the x plus 4 squared out to get x squared plus 8x plus 16. And then you have to times that by x plus 4. So then you have to multiply by x squared, and x times 8x, x times 16, and then 4 times x squared, 4 times 8x, and 4 times 16, which will give you this. If you then tidy that up and bring your 8x and your 4x together and your 16 and 32, it will leave you with that. And then you can differentiate each individual part. So take the 3 down, move it to 2, multiply down, move it to 1, and the 48. Now, that's a big cumbersome process, a lot of algebra involved, and the potential to making mistakes is quite high. But let's look at what you can do here. If we take a common factor of 3 out, we leave x squared plus 8x plus 16, and then if we look at that again, we've got 3 times x plus 4 squared. X plus 4 squared will multiply out to give you this. X squared, 2 4x's put together, and 4 by 4 give you the 16. Now if we look at this result, compare it to what we started with, then what's happened is the 3's moved to the front here, and then it's reduced by 1. The brackets stayed the same. Now that's exactly what's happening here, and if you look at this, there's a pattern starts to emerge. So if you look at all these functions and then the derivative, this one here, the 3's moved down when you differentiate and it's reduced by 1. In this case the 2's moved to the front of the bracket and it's reduced it to a 1. And this, if we want to differentiate this, we've got 4 in the front of the bracket and we've taken 1 away. So really what's happening here is the brackets staying exactly the same, and we're just using our basic rules of differentiation, multiplying down to the power and reducing it by 1. Again, you can see that happening here. We take the negative 2 down to the front and reduce it by 1 to get negative 3. The fractions are the same. Take 3 over 2 to the front and subtract 1 from that, and it'll give you a half. When we're doing the trig functions, we have to look at the trig function and we differentiate that. So we differentiate sine and you get cos. So the derivative of sine x plus 4 is cos x plus 4. Okay, let's look at what happens when you have a coefficient in front of the x, i.e. not just a 1. In all these examples here, we're dealing with 1x. But let's look at what happens if there's a number bigger than 1 here. So again, if you wanted to differentiate this, you'd have to multiply all this out like we did before, multiply the brackets out. And you could do that by doing this. Same principles before. Multiply this out, get 4x squared, take away 6x, take away 6x, and a plus 9. And then do the same thing, multiply that by that, and this by this, and the 2x by the 9, and the 3 by the 4x, or the negative 3 times this, and negative 3 times 9. You'd end up with that. You can simplify all this together. You're going to get a negative 36x squared, and a 50, you're talking 54x. Once you get it to there, you could differentiate it, multiply down with 3, take away 1, and so on. That would give you this. Take a common factor out of 6, and then factorise that, which gives you this, 6 times 2x minus 3 squared. Or you could look at the 6 in terms of a 3 and a times by 2. Again, this deserves more attention here. What's happened up here? Well, the 3's come forward, it's reduced by 1, and then we seem to have multiplied by the 2 here. So let's look at that in more detail here. So all of these are functions, and this is what the derivative is. So in this first example, the 2's come to the front, we've reduced it by 1, and then we're multiplying by this number, sorry, here, this number there. Again, if you're differentiating this, the 2 comes to the front, we're reducing it by 1, and then we're multiplying by this number here. Now the thing we're actually multiplying by is really the derivative of the bracket. If you differentiate 3x plus 5, you get 3. If you differentiate 7x plus 1, you get 7. The same idea here, if I wanted to differentiate this, multiply down by the 3, reduce it to a 2, and then multiply by the derivative of the bracket, which is 2. So that's why I end up with a 6 at the front. And here, multiply down by the negative 2, reduce it by 1 to get negative 3, and then multiply by the 5. So that negative 2 times 5 will make negative 10. And skipping to the bottom one, if we differentiate sine, you get cos. And if you multiply that by the derivative of the bracket, which is 3, you get 3 cos 3x plus 4. This is known as the chain rule, but it's easier to see just doing this method here. And I'll show you that in more detail in the next lesson.